Am I not seeing that?
Right.
Over there.
Yes.
See the thing there?
Oh,
So, all right, so let me come back to this point about communicating things to others. So I've had analysts that have come and worked with me, and they get so far into the weeds, they come and talk to me, and it's like, whoa, 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 back up, make it intuitive, because you're running 100 miles an hour, you're running around and getting into too many weak things. I need to back up to 30,000 foot view of the world so that things are very approachable and understandable. So this comes down to being clear about what your research is trying to answer, and avoid the weedy details unless they're really essential to the points or the conclusions that you're making. And I think in describing how you whittle down your data, that's sometimes a hard thing to do, is to say, does the reader really need to know this to understand or not? So I would be asking that all the time. Does the reader really need to know this? And if they don't include it. I liken it to a friend of mine was making a film, and he had done a lot of filming and everything, and had all this film that he had taken, and he could not figure out what to cut out and what to include. And if you include everything, it's just too long and not really to the point. So I think that one of the hardest things for you to do initially is to know that you can cut stuff out and things will be okay. I think you're more prone to include more than take things out. Simpler is better. And the only way you get to know that is by trial and error and getting feedback. So another thing is, how do you communicate your data, engage your audience? Humans are very graphical. We like to see things. It's easier for us to, look at a figure and have an explanation of what's going on in that figure, so that you have a better understanding of the relationships that you're after. Brian will tell you that this is my pet peeve. Not my pet peeve, but it's become, I've been more vocal about it. I used to just say, yeah, that's what it is. So I'm colorblind, 2 in 10. We've got 10 people in here close to it. 2 of us are colorblind. Never put green and red together. Never. And no one knows that except for a colorblind person, because we can't tell the difference. They look exactly the same. And I will point to a line and say green, and they go, you must be colorblind, because it's actually red. Now, if it's like big, bold, bright red compared to big, bold, forest green, no problem. But none of the graphical packages do it that way. It's always these, light shaded red, light shaded green, and then you're dealing with a teeny tiny line that doesn't have enough magnitude to really help. So, in the prehistoric days, we used to use dashed lines and solid lines. They were black and white. Life was good. So, and I don't know if you understand what this means here in terms of how you communicate across varied audience. But see, I kind of think you, in terms of how you communicate, you know what you know. You know tons more than your typical audience. Your future self is going to learn even more, but you're not there yet. Your co-authors, or your economist, probably you're gonna have to communicate more to them, and the public is the one that least understands what you're gonna do and what you're doing, and so they need to have things really spelled out to them in a very clear, concise manner. And I would just say, how much writing do you guys do in college now? Do they make you write a lot?
Yeah.
Yes.
Do you get good feedback on your writing?
For the most part.
Because no matter, being a good writer is not easy. And I've always approached it from the standpoint of saying, I've never been a good writer. I always need to get better. And so I'm always really thoughtful about what I'm doing in my writing. And for me, that's been, it's been helpful because I never assume that things come out. I can never not, even my emails, I draft and rewrite. I never just write and send out. I always have to, read it, change context, things like that. And so to me, writing is really important, not only for this class, but for your career and for your, my wife was in communication. So what do you think? She's like a communication wizard. She can do copy. You know what copy is? So in communication, all the people on TV that are reporting, they write copy. That's what, what they do. What they're gonna say, what they're gonna report on, things like that. Well, she's such a good writer, she can write copy in 3 minutes that would take me 30 minutes. And that's because she's a communications major. Some of us aren't that good, takes us a little longer, needs more input, have people read it for us, give us feedback, so all of that, and that's kind of really what we're gonna be doing over the next month as you get to turning in your final project. Okay, so that's a communication standpoint. Now, how do we do that? What's an easy way to do that? Well, let's take a particular research idea into thought and use that as kind of a way to learn and understand how to do this. So we're going to be looking at this Redfin listing data, and this is house listings and what have sold in the DC area. And a hypothetical question is asked of you to give some feedback to some policymakers like the DC mayor about what affordable housing project would look like in the city, and to be able to see what a good housing project would be, what are the factors that go into home prices in DC. And we're gonna look at this Redfin data to really tease that out. And so how can we look at that Redfin data to really figure out what's changing, how prices change and are affected by certain factors, and then use that to then come back to those policymakers and explain to them what you've learned and what you've found that will help them to then design an affordable housing project in the city, in the DC area. So we're going to use this Redfin clean CSV file that's in the Canvas page, so you can download that. And this goes back to something that we've been doing all semester, is the who, where, what, when, why, and how of the data. And the who is all the homes that were bought and sold, where in this particular case, it's in the DC area and then in Maryland and Virginia. It's gonna have particular characteristics of the house. It's only for the month of September of 2017, so it's a little out of date, but it's relevant to what we wanna kind of spell out here. The why, it's a searchable real estate listing. It's kind of like Zillow and everything else, and the how, it's maintained by real estate agents. And so they collect it and provide it for public use and things like that for this reason. In addition to what's found here, we've added this metro distance variable, which is going to be, everyone familiar with the Metro DC their mass transit's called the metro. So it's how far away you are from a metro stop. And so we're gonna use that and add that to our data set. So do you want to look at it this way, or do you want me to do it on within our studio?
That's fine.
This is okay?
I'll just type it. See.
So, in fact, let's see. Let's just do this. So I can show you. So here's my code, and I'm gonna go ahead and read in the data. Okay. And then go ahead and take a look at the data, and that's what you find here. And let me flip back so that we can see it more here. So we've got just over 1,100 observations, and we have 18 different variables. 18 variables are here. Okay, and we can see that it differs in terms of, it's looking at this identifier for a particular cell. This must be like a listing number that denotes a sold house. The address associated with it, it's a past sale, not a new sale, when it was sold, when it was listed, so we know how long it was on the market, whether or not it was a condo, co-op, or whether or not it was residential. The city, as well as happened to be in that state, zip code, price, beds, baths, square footage, and things like that. So, here. I would then produce a table like this in my presentation, and in my analysis, and in my paper that would list out the mean, standard deviation, min, median, and max for the relevant variables that are here. Now notice there's also like listing date, there's also address, there's also zip code, things like that. I don't include that because I don't think that that's going to be important. And so I'm not going to probably be using that in my analysis to decide what factors go in to the price of a home. So you can kind of think of each of these as being relevant to the overall price that is the home is sold for. And if you look at these 7 variables, one of which is the variable that I'm after, and the other 6 are really those things that I'm used to explaining the price. If I come back up to here, am I missing anything? Is there something there that you think might be able to help me better explain price that I've left out of here?
Can you go back to the other slide?
Sure, I know, I'm kind of, and this is price per square feet.
Oh,
What's that?
Was year built
Yeah, right here.
on the other one though?
No, it's not. What you're thinking, Dion?
And this is looking for like relationships in like price?
Yeah, what do
I
you,
feel like-
so things that would either lead to a higher or a lower selling price.
I think like a newer house would have a higher selling price.
Okay, now, that's great. 1964, 66, 2006. When was this data?
2017.
2017. So to get after Dion's point, can I just use this, or what do I need to do? Dion, you said that you think a newer home would be
More expensive.
than an older home? So I need to do, can I just run with year built, or do I need to do something with it?
You need to know the price of it when
Or
it
like-
was that
We've
year.
got the price, but
Like the age of the home?
yeah, so how do I do that with year built?
Yeah.
There you go, I just take the difference between 2017 and the date here and call that age. And I could do that and then see whether or not what Dion suggested holds. And so even though I've only done it for 6, there's other things that we could get out. Another thing is that, you know, zip codes, is refined enough to be able to capture a lot of demographics just by itself. So that you could say, well, this is a primarily Black neighborhood or Latino neighborhood, whatever, just by using the zip code. Now, I can't do a transformation around that, but zip codes are a natural clustering. It's a natural way to, you know, sort by, right? You can group by zip code and do a lot of this too. So there's more here than just simply that would explain the price of the house. These just happen to be ones that are numerical. And you'll notice, you know, is there anything that kind of jumps out at you here when you look at these summary statistics for the Redfin data set?
The price of the house, like the mean price, is pretty expensive.
Yeah, and
the
how
range.
does that look relative to the median?
Yeah, it looks like pretty big of a jump.
Yeah,
So that tells like the skewedness because, oh wow, that's why. And then the min is also very low, which is like alarmingly low. And the max is alarmingly high. So it's
okay.
like the outliers are very, very drastically different, which is.
So if I look at this, any ideas, do you think that, what would you think? I don't really need to explain this, but I wanna go and look at the data and pull this guy out and
Yeah.
see what's going on there. And if it's a giant house that has like tons of square footage and 12 bathrooms, well, then maybe I'm not that concerned. I only have 8.5 bathrooms. I've got 12 beds, maybe bedroom, maybe that works. But this is really an outlier and maybe I just throw it away. Okay? But that's what this helps you with. And so you would put that in your project report and explain it and do kind of what we just did there, where you would say, everything seems reasonable, nothing kind of is jumping out. So do not put a table in and if you're not going to talk about it in your text. Or do not say, you know, I reported my summary statistics in table 1 and then go on. You've gotta tell the reader why that table is important by telling him or her to go and look at it. And in this case, you could say, hey, this is helping me identify an outlier. And then point that out and explain it. Okay. So we kind of already talked about this, and Dion gave us another variable that might be of interest to us in terms of the age of the home. And so let's just go ahead and think about it from this context. You've already added to that. You can tell me what your initial thoughts are around price and these variables. So if I come to you and I say, okay, what do you think the relationship is between price and square footage?
The more square footage, the higher the price.
That's what I would expect, kind of the same idea that a newer home is more expensive than an older home. Metro distance, any idea?
The smaller the metro distance, the higher the price.
So when I was in St. Louis, they actually put in a subway. I mean, that was all brand new. And there were a lot of people around the university that were fighting it and saying, oh, no, it's gonna be a bad thing. And the urban economists in the department were like, these people don't understand, this is an amenity. You're gonna, people are gonna find this to be attractive and their home prices will actually go up. And they looked at different cities, metro area, the DC metro and other places that had put in subways and mass transit, light rail and things like that. And sure enough, if you looked at other cities, that's exactly what you saw. And so from a policymaker standpoint, you would like to know that. If I'm like in St. Louis, I would look to, another comparable city that has put in light rail and show the policymakers that this is positively related with price and not negatively. Because a lot of people were running around and saying, hey, it's gonna lower my home value.
So,
David?
like a lot of people that when they extended I'm from New Zealand. When they extended the Silver Spring line, like a lot of their homes were, what is it called when they buy their home? So what about the people like when they buy their homes because they need the area? So they basically like.
You're talking about like a eminent domain?
Yeah,
When they extended the line, they tore up homes.
yeah. So what happened to them?
So in that case, it would be about that period of time, right? So those that are really, really close during the construction period may have a negative impact, right? So you kind of told me what you think, and you can do that, you should do that in your work, that you should kind of say, look, these are my initial thoughts, but how do we provide rigor to that? In other words, what tool do we have that provides us rigor and precision to what our initial thoughts were and validating whether our initial assumptions around these factors are actually the case? Any ideas?
Sort by.
More to think about from a statistics standpoint. We did up here, we did just summary statistics around mean and variance and standard deviation. What about here? Oops. So correlations. No, let me just actually, so here's the code. We're gonna go ahead and drop everything like year built and zip code because that's not gonna be, and then this is what we get. So, trick question. Would you cut and copy this into your document and think that that was a good table?
No,
And why not, Siobhan?
because it still has the
Yeah,
comment
yeah,
and the type, what am I trying to say? The variables, like lot underscore size, like it
yeah.
can be put clearly and just more.
I mean, I think many of these are okay.
Yeah, the price.
This one, probably not, but, I mean, if we can make these without the underscores, that would be great, because, if we can clean up. These things aren't acceptable at all, because people will be going, what's going on there? But what you can do is you can drop this thing into Stargazer like that, and you get a very nice table. So that's what I did. Which one would you rather see in your project?
That one.
That looks like I know what I'm doing. And a lot of it is just cosmetics. Okay? And so And that wasn't very hard for me to do, so let me just pull this code back up. So, this is the code that created that. Okay? So this is typical kind of code, and it's actually this code right here and there. And then I just did, all I did was I took that output that I created from the correlation command and I plugged it into Stargazer. And put a header on it, and in this case, I actually fed it out to an HTML file because I'm not in our markdown file. But I can more or less take what's found here and stick it into an R markdown file, and that's what I get. So Stargazer will give you a lot of, do a lot of work for you that makes things look really cosmetically nice. So when you look at the correlations between the different variables, since we're after price, if I run down this column, what really jumps out at you? Well, the numbers, yeah. So what does anything go against your intuition?
Metro distance? Or- I don't know, it seems like a really small correlation.
Pretty small. So should I be designing my transportation policy around this?
No.
It doesn't hurt prices, but it doesn't really, I mean, the bang for the buck isn't there, right? Extending a metro line isn't cheap. And so it's gonna be a hard sell to go to those people and say, oh, it's gonna make your property values, higher because you're closer to a metro stop. So probably not a big selling point. What would be the, what would you have to tell the mayor? Or what would you think this would help you kind of resolve around which factors are important for this affordable housing question? Okay, should you be building, so given the number, it's 0.74. What would you recommend to the mayor? Big houses or small houses? Ooh, okay, what are you trying to, remember, this is affordable housing.
Oh, small. Yeah.
And that, signs are critical here, right? And this is something where you just kind of sit back and say, okay, what's the question I'm asking? It's not about, I think we always want more of what we have. And so in this case, it's affordability. So to the mayor, you would be telling them, look, we've got to understand how big the house needs to be. Because the bigger the house is, the more expensive it's going to be, the more it prices people out. Now, Brian and I live in Johns Creek, and in Johns Creek, they have created all sorts of legal restrictions against multi-residential housing. They do that through how many parking lots, how many parking spots they have, how many square feet per acre, all of this. And the city is going in the opposite direction. They don't want affordable housing. Any ideas why the city of Johns Creek is running around saying, we don't want affordable housing, we don't want, lots of condominiums, we want, big lots with houses on them. Any ideas?
Because the price of them.
Why do people move to Johns Creek?
The schools.
Bingo. And if all of a sudden you have all of these condos and things like that, the number of students per teacher skyrockets. And that is one of the factors that they use around here for, you know, saying, oh, this is a good school, or, you know, what kind of education your children are gonna get. So, again, coming back to what is the question? In this case, it's affordability. So because square footage is the most correlated with prices, we're gonna focus on that for here. But we can expand it, we can look at the other ones. The next one, I don't know whether or not, you know what collinearity is? Where one variable is telling you the same thing as the other variable? You know, beds and baths, look, baths is pretty giving us the same. In fact, if you look at the correlation between baths and square footage, it's the biggest one on there, 0.84. So am I getting any bang for the buck by adding baths? No, in fact, it would pull away from square footage, and there's nothing that I'm getting from it, so I'm not gonna do it, right? So this table tells me quite a bit about relationships there. Doesn't tell me what's causing it, but it does give me an idea around the relationships. So let's go ahead and take that, and you can do it, and this is always the funny thing is, we have people in our department that produce graphs like this, thinking that colors are helpful, and I look at it and say, whoa, that's not very good. It's not helping me at all.
It's even funny to-
That is good.
So to go back to the colorblind example, usually the ski maps are done in green and red.
Yes, yes. That, so by default, it's bad.
Plus, not to mention, like, I would generally avoid using EMAS because the colors do have meaning, and like, people usually put very little thought. They usually go, oh, it's splash of color on a page, and it looks fun, but yeah, I would, unless you're very confident that it's gonna tell exactly what you want to say, avoid the fancier
Yeah.
graphics.
Taylor?
So are you saying you can't read heat maps? Like, you know.
Do you know the green and red heat
yeah.
maps? Those are like, it's like, honestly, this is what I do. This is what I've done my entire career. When people come and give a presentation and they throw up a graph and it's got colors in it, I just zone out. There's nothing there for me. I can't, it's like, he's talking about, you know, yeah, the green line, and I'm going, yeah, that's, you know, I might as well be blind.
Have you ever heard that phrase, yes or yes? That's literally like, it's good or it's good.
So, the heat maps are the worst. They're really,
So are you,
so you would, if you took blue and orange, complement colors, that works. If you know what complements are,
oh, green and red are primary.
no, green is not a primary, red is a primary color. I don't understand it either. I mean,
Yeah, like on the
I know
color
how
wheel.
to mix colors to get green. And it's, you know, doesn't have red in it.
So are you saying for a project you prefer us to use like black, different tones of black for like flashy or
Or just,
line size?
you know where your color wheel is, okay? If you're gonna choose a color up here on the wheel, choose the other color on the other side of the wheel. That generally works.
If you do a search,
Green, red.
there are a number of different color
And don't-
palettes. And you probably have to
Don't
get
worry
to-
about it for your
Yeah.
project, I'm giving you just my bias.
Yeah.
Queen's seductive.
Alright, so we're gonna look at square foot and price and we're gonna plot that and see what it looks like so that we can present to our readers what that will look, you know, what that's telling us, okay? So, I've got that there, but let me show you what I did. And does that come out very well?
No.
Yeah, so that would be a bad slice for a president.
You can use a dot size.
Well, maybe
Sure.
if you made the margin
like
smaller,
citrus.
then they'll
Use a dot size.
Yeah, well,
Yeah, well, that's why, you get the shape is a little,
That's okay.
What should I use?
just get rid of the shape.
I'm just confused.
It'll automatically default to a point.
And just keep the G on point?
Yeah, and if you wanna adjust the size, you can do the size.
Yeah, I
inside
know
of it.
that.
This is off-brand.
Is a cutie an orange or?
It's a
tangerine.
Oh,
I say it like.
What's the What's the difference?
What's the difference? So small.
There we go.
I didn't know that.
Come on, y'all. Stop.
Is it
I just thought it
tangerine?
was a baby orange.
Okay, so
Is it not?
that,
Right?
now, when you look at that, tell me what you're seeing. We've got price here, and we've got square footage here.
so there's some kind of correlation.
Positive.
Yes,
Correlation.
positive correlation.
Well, look, where is the one with?
I don't think this is
Just
the highest.
Why did it
I
just
think this is
buzz
the
out?
correlation.
It's the correlation.
1 to -1.
It's a positive correlation.
Okay, where, can you show me the point that's associated with that outlier?
All the way. Oh, no,
Is it
actually
not
up there.
Leah?
Oh, right there.
Yeah.
Boy.
The one that went all the way up there.
Oh, that's it?
Yeah,
I thought
because
it was that
no,
one.
but those are, there's more number, like they're reading that one, but that one's like,
Oh,
All
I
the way
get it.
out.
Yeah, I get it. I get it.
What do you get, Brianna?
That one is just completely in its own field, like.
What do you conclude about this listing?
square foot and right? That the home may be older, that's why.
Square.
This is someone put in the wrong number.
Oh.
You sure?
Well,
If I take off the last two zeros, it looks like these guys.
but what?
This is 1,600 square feet.
Yeah.
A $500,000 house for 1,600
What if
square
it's-
feet?
You know,
That's
there's
like
some
a
of the
museum.
houses- some of the houses that are closer to.
Right, but it's
And
like,
those
yeah,
kids'
but it's
houses.
McLean, Virginia.
No, but, okay, so some of the
Yeah,
houses,
like they're.
Taylor said some of the houses. Here are some of the houses. Okay, some of the houses, even some of the houses aren't as expensive than that, and they're mansions.
Exactly.
And anything that has 1,600 square foot, even the things that are kind of out of normal aren't over $200,000.
What
Yeah,
if
that's
the
crazy.
old president owned that house?
No.
Yeah,
Still not worth
is
it.
it gonna affect your analysis?
No.
Probably not, but when I look and see this figure and you haven't addressed it, I'm gonna go, what's going on there?
And what do you mean by addressing, like, talk about it or remove it?
Provide saying, look, I could have started with Taylor's argument and then kind of gone through that. I mean, you have, give the argument as to, should I include it or should I exclude it? What might happen? Look, this is $450,000. Everything else in this, kind of size house is ranging between, $50,000 to $200,000. So,
So I think what Mark is really trying to get to is that when you start communicating your results, the first thing that a professional is going to do is they're going to examine your data, and they're gonna wanna know that you took care with your data, that you understood your data. And the biggest red flag that stands out to everybody are data points like in the top left corner. And that sort of at a very fundamental, really begins to call into question, okay, if you didn't even investigate a single data point that really stands like a sore thumb, how much care did you put into the rest of the analysis?
yes, so I will have an analyst come into me, I will have my research assistant come into me, and they'll tell me about all the stuff that they've done with the data, and the first thing I will ask them, I go, well, did you plot it? And if they haven't plotted it, I don't trust it, because plots tell them a lot about whether or not it's the data they thought they got. And often I'll come in and they'll go plot it, and it'll look something like this, you know? And I'll go, what are these? That doesn't look random to me, that doesn't even look like, so by plotting, you can find out whether or not what you did in a transforming and things like that, or cleaning, worked. This could have been just simply like, the 999.99 that Brianna deals with. Right?
That's exactly the example I was thinking of, you plug
And
it in and it's
I gotta
fine.
figure out what to do with that. That just doesn't seem right or normal, so, and that's why graphical, you'd see that quickly. And you can convey it quickly that, that I don't have that problem here. Yeah, I got something going on here, so let's be a little careful about it. Is it gonna drive my results? No, but at least I wanna be, the reader's gonna ask me, what's going on then?
And does it happen in presentations? Like, yeah, like, it's often that you'll have funny little anecdotes in the middle of the talk about weird outliers in the data.
Just showing that you've thought hard about what you're doing. From a report context, are you okay with the cosmetics of this thing?
No.
And why, what would you want to do to make it cosmetically nice?
Label, title.
The numbers? I hate scientific notation. No one knows what an E is. And then they have to do the math that helps them understand what that number really means. Which is fine if it's a really, really small number. But in this case, this is a number, and so, just work on things like that. It's best not to have your labels in scientific notation. And so I could come in here, and I think that that's what I did. I went ahead and just divided by 1,000. And by dividing by 1,000, I could get that right. See if I've got it here. This is what it would be, price divided by 1,000. And then let's run it. And then, I'm not thrilled with this either, but now you at least get numbers here that are a little bit more, easier to understand and see. All right. So we have that where we've divided by 1,000, cleaned it up, went here, put in some labels and things like that, things that Brian went over like last week or 2 weeks ago, and how things should be done, titles, making it very accessible to the reader. I'm with Brian, I do not like that gray background. It looks bad, kind of looks like it just got plopped onto the page. I like to make it part of the page. So let's come back, and you've kind of already answered this. But do you know what I mean by linear? Is there a linear relationship here? Which means it's a constant relationship, it doesn't really change. There may be more uncertainty around it, but there's kind of 1-to-1 or 2-to-1 or 3-to-1 relationship between square footage and price?
Yeah. It seems
Yeah,
to be a
Because,
positive
let's see if I
correlation,
can do this.
but weak.
If I'm just eyeballing things here, I would come in and say there's kind of a linear relationship that looks like that, right? Somewhere around there. And really, that's where linear regression and ordinary least squares is gonna be helpful to define what that line is, that minimizes the difference between the observation and the point over all of the different points. I mean, the observation and the prediction over all the different observations. So, and so that's really where we're gonna go. Let me ask you this. On project update 5 or thereabouts, I asked you to kind of create categories where you had a variable like square footage that was continuous, that had numerical values. And I said, can you group these things into different categories? And then I had you then perform conditional means and conditional t-tests around that. What would that look like here? Blow this up a little bit so I can work with this. And why would I need to do it? So let me kind of show you what I'm talking about. So what project update 5 did is it said, okay, let's go ahead and partition my data kind of in this way, where I'm going to create a group of all of those homes that sold that had a square footage between 0 and 2,000. So this would be group 1. Sorry. This would be group 2. This would be group 3. And this would be group 4. And so for this particular transformation of square footage, I would then have like a 0 here, a 1 here, a 2 here, a 3. Those would be like the labels on those, right? Does this make sense in terms of what you've done?
Yeah.
And then once you group those, you then went in for that particular group and you calculated the average price of the sales of each group. And so let's say that that's right around here, that's right around there, that's right around there, and that's right around there, right? Does that graphically make sense? And then the next step was to say, is group 1's mean different than say group 2's mean? And so on and so forth between that. And that's visually what you were doing. Because we didn't have linear regressions available. This is a good starting point. This is really a nice way to kind of break things down. Now, you did have to choose what these boundaries were between the groups with regards to the square footage in each of you. I would have to explain why I did that. I would have to justify that these groupings make sense. Maybe it's just for convenience, but at least I have to provide something around, hey, this is why I did it. It's just floppy. If I did group 5 and I had a factor of 4, am I okay to do my analysis?
I mean, it's only one.
There's only,
Yeah.
yeah, Brianna, how much inference, how much prediction can I get by just looking at one?
Yeah.
No, so So it doesn't make any sense to do a a fifth group, because it only has one guy in it, and that's really not helpful. So I need to make sure that my groupings are such that I have enough observations in them to be able to make good inference. And this is where the standard error and the variance is gonna be so big in this group 4, that it's gonna require a lot of information to be able to say that its mean is different than, say, this group 3. Okay, so that's kind of what you've been doing. And what we're gonna do today is we're gonna come back in and say, look, my linear regression will tell me the same thing and tell me whether or not there is these differences, not only between the groups, but between different houses based upon their square footage. And I think it's important for you to kind of understand that, because like I said a number of times, we're visual, we like to see things. It's helpful, it allows us to make things very intuitive. And that's kind of what's going on here. And so, leverage a graph in the way that you want to be able to say that. So, you told me that there's a linear trend. What else could you tell me? Where do you think you're going to get the most power of explanation in this data? For big houses or small houses?
Small.
And why small houses?
Eat a lot.
Because I got a ton of them in here. Where if I was just looking at this guy, not. So we're seeing that it also tells us that my population really consists of, a majority of them being 2,000 square feet or less. So could have I done this with bedroom size? Yeah, I could have blocked it up with regards to bedroom size and gotten something darn close to this, right? It may not have been as kind of clear about size thing, but it definitely would be similar. So I know each of you have something similar to this. So I think we've talked about all this. And in the end, again, it doesn't need to be perfect. You don't need to explain it, or, explain everything away. You can just, as Brian said, it's convincing people that you've looked at it seriously and have asked yourself about it. Okay. I think this is an interesting question where it's asking about what's the difference in the expected price of a house that has 1,000 square feet as opposed to one that has 2,000 square feet. And from what you've told me thus far, you would expect that the 2,000 square foot home would be bigger than 1,000. And that's a very binary relationship. That's what you've done up until this point with regards to Project Update 5. Is it more expensive or not? That's your hypothesis. Where here, you're able to come in, and what we're gonna show is how you can then say, how much? How much is a 2,000 square foot home on average more expensive than 1,000 square foot home? And that's where our linear regression is gonna be able to give us that. And that's where we come to this nice little regression equation where we say that the price of a home is a factor M of the square foot and an intercept term, okay? And looking at the graph, what do you think M would possibly be?
Slope.
It would be the slope. And we need to figure out, is it positive or negative?
Positive.
Positive. So we need to figure out what that looks like. Okay. Well, I'm gonna just jump a little ahead and show you that the nice thing about, ggplot is I can use this smooth option with method equal to LM, which is linear model, to be able to put that line into my scatter plot. Let me run that. And there you go. Now, the problem I have here is I don't know what M is, but it would be the slope of that line. And so I need to be able to do something in R to tell me what that M and that B in that equation are equal to. But that line would be a line that would minimize the distance between every single point and the points on that line. And you've seen something like that before, right? And if we wanted to do it in econometrics context, I could take a particular point and show you how much is the error and how much is explained, and then how we come up with a lot of the test statistics that we use in this context. Okay. So we're gonna be after the B and the M and try to figure out what those are. And I think a lot of this stuff is just kind of setting that up, and I find it's just gonna take more time than what it really provides. So let's figure out how we can pick that best line that I've just given you. How can we come up with a way to compute it and show you, okay? So why don't we go ahead and have, 10-15 minute break, and then we'll come back and we'll finish off with showing you what linear regression looks like in R. As I did show in this disclaimer, is that it's not, this is not econometrics class. The fact that you've had econometrics, a lot of this stuff is familiar to you. And if you want to use it in your presentation and in your project, we're more than happy to help you with that. Okay, so let's come back, let's say at 10:35. Any questions? Good.
So I got my dual access plot to work. But it doesn't work in ARMWork.
Huh.
Yeah.
Save it as a image and then load it in. Save it, you can save it as an image and then load that image into a markdown. So,
Okay.
so if you're having issues with it, that's great, isn't it? Okay, yeah, just save that in, so in your R script, save that plot as like a JPEG or something. And then just load that in.
Okay.
And like,
So, yeah.
Don't
Don't even make a
they
face.
don't really build it. Because this is. 10,
On my notes,
but
so is it, it'll say like this time series or something.
yeah.
Until when?
So not.
The first thing it says is this course covers the metric, linear models of classical linear regressions. Metrics too, but. And then in IB, generalized methods. Introduction based on topic distribution based provided. Emphasis will provide this edge.
I think it's a regular class. Like, I'm really, like, I don't know. What's the English class?
I'm so mad he's not teaching more classes, I'm not gonna lie.
Him or Millicent?
But both of them, that was my,
I don't need.
That was
Like,
my
all
thing
back.
too. I was like,
Yeah.
I'm taking
Yeah, I
classes with
know.
them.
Millicent is for my econ and like that.
Yeah.
I know.
no, yeah, she's just such a piece of
Yeah,
cake.
right, so I don't think it-
My
it's
problem
like,
will be similar.
You go to a review, but.
I talked to her
Oh, how's her?
and she was like, I
How's
just gotta
her,
go for
Let's
it.
go some of the math
seminar?
courses.
She's
relationship where Y, in the context of our problem, is gonna be price, X, and that's generally what we refer to as the dependent variable. Because that dependent variable price is gonna depend on square footage, which is X, which is the explanatory variable. M is that relationship, it's gonna, some people, it's a coefficient, and B is the intercept term. And so we'd like to be able to estimate those and then be able to test whether or not that parameter that we estimate for M is significant or not. And we'll talk about that, and it'll be a little bit of a review around hypothesis testing, but now how it extends to this particular case of a linear relationship, okay? And all we're trying to do in this particular case is, you know, make the difference between all of the different observations that we have in this line that we're gonna create by choosing an M and a B as small as possible, okay? And as it says here, it's just minimizing the sum of squared errors. And any idea why it's the square and not just the error?
So that it's like not negative.
Right, so we're not saying we just wanna minimize errors to the positive side, we also wanna minimize the errors to the negative side, and the square gives us that. We could come in and put absolute values around that, be kind of similar, but it would give us a different result than M and B. And that's what we kind of think of as how we want to evaluate the risk of being wrong. So you can go ahead and look at this pretty easily and say which one's the better fit, right? Don't ask me which color is which.
Oh, sad.
I know that this is red. This is one of the few that I can actually see. And then you probably go, no, that's green. No, this looks red because it's fat enough I can see it. This looks green.
Yeah, you're right.
So it's not like clearly just like black and gray?
No, I can see a color. I just can't. It's kind of like this. Sometimes I can't really tell the difference between the colors. I know there's a color there. But if you ask me, yeah, is it green or if it's red, I don't know.
Yeah.
It's like a labeling problem. Plus, you know, people come in and they say it's fuchsia, and it's like, what do you mean?
Here's about just say pink.
That's pink, isn't it?
Yeah.
That would be my kind of response. Okay, so here's our particular question. Price being a relationship of square feet. We really want to be able to estimate the B and the M, okay? We've already kind of talked about all this. And so we go back to that question about how much would a 20,000 square foot home price on average be different from 1,000 square foot home? All we would have to do is take 1,000, because that's the difference between the two sizes of house, put 1,000 in here, then multiply it by the M that we have and the B, and that would then tell us how the price was difference between the two. And that would give us an idea of on average, how 1,000 foot home or 2,000 foot home is more expensive than 1,000 foot home, okay? So what we're gonna do is use this function that's called LM and R. You might as well show you this. But LM is short for linear model, from what I always thought. I mean, so if I just come down here and type question mark LM, you can see fitting linear models, used to fit linear models, including multivariate ones. In this case, we're only using one variable, in other words, price. If we were looking at two variables, then it would be like price and, what else we have in there?
It'd be like square footage and metric distance or something,
I
right?
don't think we have any data that allows us to entertain that. And then you've got an explanation down here, but the part that I want to kind of what I wanted to do is focus on the formula part. The formula is how you define the actual least square regression that you're after, and then you just put in the data, and there's some other things here that play a role. If we come down here further, you get examples of it. And this example here is you're taking the dependent variable and regressing it on the explanatory variable group, and this little tilde, which is above on your keyboard over to the upper left hand right, to the left of the one uppercase. The tilde is just the operator that you use in R to spell out that relationship. And so in our particular case, the Y and the X is gonna be price and square footage. And so we would just put that in, and then we have to put in the data set that we're using here, which is that Redfin data set. And we're just gonna capture the output from that in this object called price mod. And then that then carries all the information that we need within it so that we can pull it up and look at it. So let's go ahead and apply that in our data set. And so you can see here, I'm gonna call it OLS1. It's gonna be LM price tilde square foot data, just like we said. And if I run that, because I've saved it to OLS1, I'm not gonna get any output. But let's just go ahead and look at what that thing looks like. And maybe just go back to this. Yeah, like that. See if I can blow this up and just move it up. So if I just simply make a reference to the object that I saved the output of this linear regression to, OLS1, all it basically is telling me is what the intercept is and what that coefficient is, M. So if I tell you that there's a linear relationship between square footage and price that is 312, how much then is a 2,000 square foot home on average more expensive than a 1,000 square foot home? So you got a difference in square footage of 1,000, that's 3 zeros. So move that decimal place 3 zeros to the right and you have your answer. So we're right around 3,000, right? Is that right?
No, like 31.
Or am I one more off? 30,000, sorry.
Yeah.
So that's what you then would report to the mayor, that on average, a 2,000 square foot home is $30,000 more than a 1,000 square foot home. And if you were the mayor, what would be your question?
How can we make it more affordable?
Okay, what would you, having taken this class, what would you be concerned about? This comes back to this robustness. You said that I've got a lot of houses that are less than 1,000 square feet. Not as many. Let's say that I came in and asked you the following question. Going back to this, what about how much more expensive would a 7,000 square foot home be than a 1,000 square foot home? And would that relationship, would it still be, in that case, it would be, 7 different, so 6,000, times 3, 90 grand, something around, 180 grand. How much, how reliable is that? That it would be 180 grand more for a 7,000 square foot home relative to a 1,000 square foot home. How reliable would that be? Well, you have so little out here in terms of the 7,000 square foot home. It may not hold as much, and there'd be less certainty about that. And that would get back to how well that linear regression explains the entire data set. Do you remember what you used in that situation?
Mark, is that right? It's not 30,000, it'd be 300,000, wouldn't it? So you got 3 zeros at the end of that.
You got 6,000 as the difference.
So now I'm talking about just with the first example, right? So if I just want to take the difference, there's 1,000 square foot difference between the two. So it'd be $300,000 difference.
You guys have the calculators, times 312 by 1,000. You add 3 zeros to it.
Yeah, 300,000.
Where are you getting the extra zero?
1,000, 3 zeros.
Yes, 312.
300,000?
No, 300, yeah, it's 312.
Yeah, 300,000.
Yeah, it is. We just.
That makes sense, because those are priced in thousands, right?
Yeah, that makes sense.
So that gets you from roughly
Okay, yeah,
500K to, I'm gonna call it just under like 800K.
yeah, because the average home price of a home
Right.
with 1,000 square feet is about, what,
That makes good more sense.
500, are you saying?
Yeah, it's like 400K. Right? So 1,000 square feet is like 400 and something K.
Yeah, this is where you need to get your units right.
No, go back to. Yeah, there you go. Price. The average price is 610. You look at your chart, the scale is in basically, yeah. So that first hash mark is a million.
This,
Go up, yeah, go up a little bit. No, that's 500K, and the next tick mark.
Oh, cause it's in thousands.
Yeah.
Oh.
Yeah, so that first tick.
all right, yeah, okay. Thanks, I was off at 0, because I kept thinking of this as being, yeah. So
I was
this is
thinking of the
500,000,
500K,
this
yeah.
is a million. So it would be 300, because then that distance makes sense. Okay. So the math still works, in the sense that if I take this and multiply it by 1,000, you get $300,000. Okay, so all I'm doing is taking my estimate of M, which in this case is 312. And I'm taking the change in square footage, which is 1,000. And that will then tell me that the change in price is equal to that 1,000 times 312, which is 312,000. So that's the change in price. Now, getting back to this question about whether or not I'm getting as good a relationship for, smaller houses as opposed to bigger houses, that then means that I need to look at what's known as an R squared. And so to get to that, I run the summary command. On the object that I'm interested in, and I get all of this information that's found within that OLS1. So tells me kind of the relationship that I've estimated. It tells me the residuals, how big the residuals are. In other words, what I haven't explained with the regression. tells me the coefficients, which we've already talked about. Here's the 312. The intercept term is a big number. So maybe I'd like to divide things by 1,000 to be able to make things a little easier to deal with. But down here, it's also got an R squared and adjusted R squared. Do you remember what the R squared is telling me? It's how well my least square is doing in predicting each of the individual observations. And so it's probably doing pretty well for those homes that are right around 1,000 square feet, but not as well for those that are out there by kind of looking at this. How much air is there between the observation and the line for something around 1,000 square feet? And how much air is there between an observation that's say around 7,000 square feet? There's a lot more, the predictability of this line is better down here than it is out here, right? And that's why this R squared is a number between 0 and 1, and it's only 0.55. So there's still quite a bit that's not being explained. And that's why you got a lot of space between the observations out here on price and the predicted value from my regression. Now, you'll notice that it's got a standard error, a t-value, and this p-value here, probability of a t-value being greater than t, and then some asterisks out. Any ideas what these are? So this is how you do really quickly a very straightforward, simple hypothesis test around, say, whether or not this coefficient m, which is 312, is significantly different from 0. So let's just write it out so that we can see it. So remember, we've got price is equal to m times square foot plus b, and we've said that m is 312 plus 1.207 e to the plus 5, a big number. And if I look at these t values, let's look at the one for square footage, which is the m. That is a test whether or not m is equal to 0 against the alternative that m is not equal to 0. That's what these tests are doing here. And so that t value is a t-test, and it's equal to 37.679. The probability of the t on absolute terms being greater than 37.679 is really small. What does that tell you? Well, if we go back and think about what we did with hypothesis testing, we got something like this, okay? It's saying that m is equal to 0, that's the null. And we're getting a t-test out here of 37.679. And it's telling me that this area out here is 2e to the minus 16. Would I accept or reject the null hypothesis here? What do we compare that to? Our significance level? let's take it to be 1%. Is this smaller than that?
Yeah.
Yeah. And so in this case, you would reject the null hypothesis, which says that there is a relationship going on between square footage and price.
Mhm.
So we know that the coefficient isn't 0. We've got statistical evidence to reject that it's 0. So it's a positive line. The easiest way to see this is the 3 dots or the 3 asterisks. If I come down here and look at it, the 3 asterisk says, oh, you're actually significant to the 99th percentile, 99.9 percentile. So here I just talked about the 1% significance level. I could go all the way up to the 0.01 significance level. And so we generally report our results for linear regressions by putting asterisks on the coefficients so that people can just look at it really quick and say, oh, that parameter value is significant, where in this case, it's at this particular significance level. Now, you don't want to report it like this. This is kind of ugly and kind of the same way that Shivai said earlier about the correlation tables.
That's you.
We want to make it much more approachable, and so this again is where Stargazer is a quick and easy and clean way of reporting your results. And so it creates a nice little table. You can put a label at the top, it numbers it, everything. And notice that, again, you get here, instead of having those asterisks at the end of the row, it actually puts it as a exponent on the coefficient that's been estimated. And so as a reader, I could just simply look at this and say, oh, well, each one of these dots, asterisks, is saying that it's significant at a different, significance level. If it only had one dot, it would be what, 90%. If it has 2 dots, it's at 95%. And if it has 3 dots, it's at 99%. And it's all found right in that table. Does anyone know what this 8.298 is?
The standard.
It's the standard error. So for me, this is kind of an ongoing debate. Should I put the standard errors there, or should I put the t-stat there? Because if I put the standard errors there, then I kind of have to do the calculations in my head. If I put the t statistic there, I can then look at the t statistic very quickly and say, oh, what's the general rule about a t-stat? If it's bigger than 2, you know that it's significant, right? Because 1.98 is 90%. Isn't that right?
1.96.
1.96 is it 90% or is it 90?
95.
95. I think it's 95. Yeah. And so I could quickly look at the t-stat and say, oh, well, this number 37.679 is way, way, way bigger than 2. So I know that this thing has to be significant. Where if I look at the standard error, it doesn't, I don't have that in the back of my head to help me be able to make that calculation. But I'm not, that's just preferences. But I've got everything I need in here. Now, when I created this table, I told Stargazer to drop out the R squares and things like that. Because from my standpoint, for what you're doing, you don't really need to worry about the R square and whether or not it's significant or not. But everything in here fits right with what you could be reporting. And that's a great table. And then what do you think you would have to do in terms of your text with this table? What would be interesting to say about it? You can verbalize things that we've been talking about thus far. You'd say that one thing I would say is kind of to explain what this number means. Kind of the way that we did with the 1,000 versus 2,000 square foot home. Also, that it's significant, meaning that there is this positive relationship between the square footage and the price. And things like that. I know that this is maybe a dumb question, but when might you use this as opposed to this?
Use what?
Maybe when you're just looking at the data for yourself to understand, and then when you're breaking it down for others, you can use that table.
Yeah. So if you're coming to me and talking to me about your regression, I would like to see something like that. Because then it's got everything and I can look at things and really kind of dive into it. It's also got the residuals. So it's just, everything's there. Where in this case, you kind of summarized it towards what you want the reader to know, okay? And that's pretty much it. And there's, you know, the code around this is really easy. Stargazer, for the most part, is pretty, for what you're getting out of it, the cost involved in that you have to do to put into the R to get it is pretty minimal. And so that's why I've always been a big Stargazer fan.
So you can only do regression for Stargazer, or you can just producing the chart.
No, you can, Stargazer is just a way to represent it. So remember, we did the correlation one with Stargazer, we did the summary statistics with Stargazer. So, you know, you just, in this, so let me show you this code. I don't think I have it.
Could you show us in the form of like,
So there's the Stargazer command that I used. Oh, let's do this. Let me jump over here and resume something and pull it over. In the appendix, there's an example of how I produced the linear regression Stargazer. But can you see this one? So this is the Stargazer in my R Markdown file that I used when I produced the correlations. So notice all I did here was select particular numerical values, excluded year build and zip code, and then calculated the correlations and saved that to this RenFin core variable. I then took Stargazer and I fed it in the output from that correlation command and put some, you know, additional arguments and a title around it. And that's all I did. Now, if I go back up to the summary, here it is again. I used Stargazer, I fed in the RenFin data. I again went straight to just simply those variables that are numerical, and all of that produced that nicely formed summary table. Now, let me show you then what the code looks like for the regression output. So we've loaded Stargazer. Here's my output. In my case, I had OLS1, but this is just the output from your linear model. and I just use these commands to produce it. And notice that in my particular case, I leave out all the R squared stuff, and that's what's going on here. So, if you don't know how to do it, what I would do is just simply say R Stargazer summary statistics, R Stargazer, say correlation plot, correlation table. And Google will take you right to a pretty solid example of how to do it. And make things look really good and clean and professional. All right, so this is what we kind of already have gone through with regards to significance. And that's a pretty standard result being produced by any kind of OLS package to tell you whether or not that coefficient is significant or not. I wanted to go back and ask the following question. So if I come back here, remember I said, I'll do it this way. Okay, here's my correlations. I said that it probably didn't make sense to include baths and square footage at the same time because they're so highly correlated right here, 0.84. So let's see what happens if I do include them, both baths and square footage in my regression. So in that particular case, I'm gonna go OLS2, LM. I'm still gonna regress price on square foot, not feet, right? But in addition to that, I use a plus sign to add additional variables to that. I'm gonna put bed in there. Data is equal to RFIN and run that. Oh, it is feet, sorry. Wait. Beds. All right, now that we got that, let's run it. Right, and let's go ahead and just jump right to the summary of the OLS2 and see what we get. So now look at the output in this case. So now we not only have the intercept in square foot, we also have beds. And so my regression now looks like price M times square feet plus say N times beds plus B, where M is now 319. And my N for the beds is minus 5,931 beds plus the intercept term, which is that 12K, 12.6K, big number. Okay. So it really hasn't affected this that much. Before we had it 312, now it's 319. But notice how much the t-value has declined. And that's because they're both trying to explain the same thing. Beds and square feet. Doesn't seem like beds is getting the same relationship that we would have expected before, right? Because we thought you'd have more beds, the bigger your house would be, it would lead to an increase in price. But now you're getting coefficients that's negative, which goes against your intuition, right? So it's not, because I've included two things that are really kind of correlated, one of them is losing out. And notice that this thing, is it significant or not? In other words, is the n for that hypothesis, is it being rejected or not being rejected? There's your t-value, the p-value, any asterisks?
No,
It's not.
So you can't reject that. Are you surprised by that?
no,
No, because everything's being explained by square footage, and so it just doesn't have anything to grab hold of. Yon?
So like, what does that mean? So like, if you were presenting the data, like, what would you say about the beds variable?
So in this case, what I would say is that, look, when I came to this problem, I already knew that there was a lot of correlation between square footage and beds. Bigger house, more bedrooms, right? So I've got to pick or choose between the two in my regression. There's nothing that my beds is gonna add to my prediction that my square footage did. And that's what it's saying. I can't reject this, and it's saying, hey, this guy's not helping you. Now, if there's a logical reason for why it should be in there, it should still be in there, even if it's not significant. But it was a bad regression to begin with, right? Now, let's suppose that I didn't have square footage and I only had beds. And I think that beds, the number of bedrooms, would help me explain the size of the house because I don't have square footage. Well, then I would include it. So let's do that. Let's come back here and let's go ahead and do OLS 3. And instead of having square footage in there, I'm just gonna go with beds. Run that, and let's go ahead and do summary on the OLS 3. I'll pull that back up. And what do you see? Is it now significant? It is. And it's got a positive coefficient where when it was with square footage, it was negative. And so you have to be thoughtful about what you include. And if two things are gonna be saying the same thing, then don't include both of them because it's gonna give you crazy things like this minus 5,931, which, you know, is not significant, it's not helping you, it's just, you know. Okay. And I think you understand this diagram from a univariate context for a t-statistic. So in this particular case where I'm including both beds and square footage, what's going on here is that if I look at it from a contour plot context, it looks something like this. Where it's a distribution over both beds and square feet. And now I'm taking a slice and trying to compute what the z-statistics are given the correlation between the two. And if I'm perfectly symmetrical, in other words, they're completely independent of each other, then I would not run into this issue. But in this case, they're so correlated, I don't need beds, I only need square footage. So if you're gonna do a linear regression, just be careful that you're not overloading with explanatory variables. For most of what you already have and the questions that you've been dealing with, we've always been very straightforward about looking at one particular condition. Like for instance, like Brianna is looking at earnings and how many times they've switched jobs, okay? This could be the change in earnings, this could be how many times they changed jobs. But I'm not gonna throw in another thing in addition to the number of changed jobs, I'm only gonna look at it. There may be things that help me understand how their earnings change. Can you think of something that would be similar to this? What would be correlated with number of times I've changed jobs?
Number of cities you've lived in, I guess.
Okay.
Yeah, that could be, it won't be as strong, but you need to think that through. But for most of you, you've already got a good relationship between the dependent variable and the explanatory variable to just simply do a regression like this. As long as there's continuity in that explanatory variable, in other words, that it's not a category variable, that it's actually numerical in this context, you're good to go to try to do a linear regression and get further into your analysis and provide that in your actual project. And we can come back and, look at your results and give you, guidance around that and things like that, but I think we've done all this. So let's talk about finishing the class by having each of you do the exact same thing that we've done thus far in class, but instead of price and square footage, let's do it from the standpoint of price and metro distance and see what you find out. Do you have what you need to be able to do that?
Yeah.
I think most of it is in
Fine.
the file. And I'm more than happy, here, let me do this, okay? So let me bring up my bar script so that you have that to be able to kind of follow. Everything's there, okay? So go ahead and work on that for the next 10 minutes.
I'm
No.
just doing a regression thing.
What's that?
I'm just doing a regression.
So you're doing the scatter plot and the regression output with prices as the dependent variable and distance from the metro as the explanatory variable. And tell me, and then when we're all finished, we can review that. And if you have an issue, just raise your hand and we can guide you through it.
Let's see.
Anyone have questions or you have the results we can talk about?
Not yet.
How many got a figure, the scattered plot? To get the line in it?
Yeah,
What about the regression?
yeah.
Who needs more time? Okay.
The same thing. Oh, maybe not.
I don't know. I used to be like,
But this must be like, okay, these are the first.
Next.
oh, you tried to add it? Because I was about to do that.
That's smart. I was making it harder. That makes sense.
Wait,
No, yeah. Just let me redo it like that.
square feet
No.
in Metro, you want
Oh.
it to go in the opposite direction.
What did you?
It's really go. But I get it now.
No.
Oh, this? I don't know what's right, but okay.
I think that is right. Because mine is, oh, that didn't pop up.
Oh, wait.
That's, yeah, that's for that. Yeah.
Okay. I'm gonna stop naming mine too.
Yeah.
That's
when
what I picked
named
up
it,
on
never
yesterday.
That's what I did,
These
and
are
it
personal.
didn't do it. Okay, so you did.
Yeah.
What was it?
And then
I'm trying to get my nails.
Right.
Is there a reason
I need to.
that when we name things, like it doesn't pop up, it just pops up like list?
Mine
They're
of,
really,
like,
really
23,
nice.
like, list of 9.
What do you mean?
I usually
Like-
go to this place, it's a place in me.
Like when I name,
Yeah, I don't like, even when I do,
I don't know how to do this.
I can.
Yeah, so, when you just run it, right, it takes whatever this, all this stuff is, and just spits it out here. If you save it as an object, like up here, like plot,
They were short.
that's, like, this whole thing is what it's gonna.
Oh,
And you can, what it saves are all the instructions.
Up there where-
Or plot to draw this,
Show my mom.
to draw this thing, and that's why I showed this.
Sometimes they just don't know how to do it.
R slash G plot,
The way I like.
look at all
Yeah,
that
it's
stuff
not
and
the
say,
same.
what do I need to do?
I'll be
with
finding
it?
like
Like-
you're fixing it.
Down here, like the first one, like a bunch of data, right, and then it's got layers, right, so. R says, okay, here's some data,
I had.
and then it gets to the next, is like, oh, well, now I'm doing something with this data. This is actually taking this data that's in here,
So,
and then it's now sort of adding other stuff to it, and then.
I'm scared I'm
Where
not
you
gonna
got
look at my hands.
geom stuff.
I think my hands are actually.
Like, and it starts building up this plot, right, that shows. And so all you're doing is just saving all those expressions.
I'm gonna ask you.
Do you want to import into R Markdown, or you want to
Thank you all.
send it to somebody or whatever? Yeah,
I'm still typing the codes.
okay.
I'm trying to graph it.
Sure.
Yeah,
Don't forget.
Um,
to have this-
no, I'm gonna try to graph it on my own and then I'll see if I need help.
oh, yeah,
Okay.
this was the one. I was-
Okay, because I was having the same issue. The first line wouldn't run because I was trying to name it. But now it ran.
Just do data cap.
Okay,
It's
Graph.
class.
did you name when you did the graph? Okay,
PG plot.
But usually, a lot of metric score nowadays starts off everything exploding. Metrics used instead of like actual data. I imagine just,
So you do
basic,
your
like,
own acrylic
basic
color.
type of stuff.
That's crazy.
Generate a picture.
Why you stop?
Don't mind.
I
I got like a whole, I used to switch out in the
What's the difference between LM?
Yeah, that's your, especially in
Oh.
Florida. No, why you stop? I don't want your good. What can you do on there?
I know what LM is.
Really?
There's like, there's like, there's like,
Good.
there's PLM, GLM,
Girl, you need to.
there's like a bunch of different LMs, and what they try to do is they try to give you what are called like robust standard errors. So
Why would you
errors just
stop?
kind of like explode on you.
Cause I do not, and I, now.
And don't give you like these
Well,
kind
you
of
do
weird
class
bits
teacher.
of data.
No, I
So,
seriously,
for instance,
mom
like,
did
we've got these extreme points that are the
Yeah.
outliers.
And so
Um,
she still has like
Some
the
of the more
right.
robust measures,
So she
right,
took me,
will
cause I
sort
was
of
like,
automatically
my
exclude.
freshman year of college. I was
We'll start doing
like,
trimming
I
to the
want
data,
to
right?
learn
It's like,
She took Taylor. I have a whole
So
cart
should I
full
use?
right now. I swear to God, I have a whole.
For this class, you
like
should go.
3,
I wouldn't try to get fancy with it.
I
Cause
just,
I
I
use
don't need.
PLM for my regressions,
I'm not.
but it didn't matter.
Yeah, I don't think with this data set's gonna really matter a whole lot. So when you get these really kind of, either dealing with like a ton of data, or it is a lot of diffusion to it, and you probably wanna be a bit more careful like with the processes.
Yeah.
Generally speaking, though, like, even just as like a first order, like using all.
Okay. And are we gonna use like, I just feel like it was very, like I have to use fixed effects, right?
Yeah.
For my regression. So I use
So,
the model.
see how there's the 3 dash.
Yeah, so they're gonna be doing stuff like that, and there
So
are
this is
specific
telling
techniques
you
that
how
help you deal with like fixed effects. and
So. 3 is.
You've been on a nail
Is that
tech
fixed
so
effects,
far.
random effects,
Yeah.
indicators,
I
variables,
stopped because my room.
The 2.
all that
My
kind of
shit
stuff.
used
Yeah.
I used to be part.
It can get really hard if you're just using like a standard model.
1%.
You can do it,
Yeah,
They
if
say
you
don't
don't,
because
Never
the
used
other
it, significant
one.
stuff.
yeah,
That
I
makes
bought, I
sense.
They take
bought the,
forever to stick to me.
Yeah. Okay.
You only
So in
gonna
your
get
case,
one.
you've got three, so you're significant.
Right.
I was trying to,
1%.
it was, oh, I tried in
0.1%.
2019, so I started with 2019.
This would be, this is
Let me.
I gave up too, I was like.
1%, this is the 10%.
You're right. So he has to like send out all these applications.
See, this is when I first.
This would be the 95, the single
That's good.
digits would be at the
This is
5%,
before I got
and this would be at 15%.
So you just,
So like, if we were doing our project.
You didn't like
we had
doing
to
it?
find
No.
out which
I was doing it
variables
for
were
my-
our girls.
it. But really, last.
It would make sense to run this and just look at.
You'd look at, in this case,
No, those
you've
are-
got significance on the intercept, but not on the metro.
No, not.
Mine
think
was
some-
terrible.
What?
Yours-
No, he just has an excessive amount of
Yeah.
spreadsheets on
So do you,
Um,
do you have like a card table?
So I haven't, let me go ahead and show you what, let
area.
me do mine real quick and see what you guys get.
My decision, down
I don't
to
feel
purely
like
just personal reasons.
What do you mean?
Didn't like.
Oh, my dad just wanted to show him up, so.
Nice.
That's a good
Let me
reason.
do this one
And
real
I'm
My
quick.
mom's lord of the fact that she's accepted Stanford for all these years.
She's worried like she got accepted.
You had to?
She's good.
Oh, she'll go.
I don't.
So it's.
Okay, last
She
year.
where?
She'll know.
Hey, wait, what?
She's good.
First of all, I was looking for
Went
hairstylists
to nowhere.
for
She
so
got
long.
accepted.
And I be looking for nail tips too.
Oh, we should go to college.
I do my own.
Wasn't the
I be
first?
doing her quick.
Had you?
My hair's literally-
My mom.
I
My
got
hair
my,
is heat.
I literally
Oh, okay.
did a quick on myself, and my hair is literally braided up, cause I can't.
That's cool.
I don't know how to
Maybe.
do
You ever asked to go to
I'm
Stanford?
scared. I don't like it, because I'm scared.
Or
Like my-
Stanford.
Stanford, Florida.
It's on the cap. It's like on the cap.
What about?
It's like my grandfather used to say he went to MIT.
Oh, I put a cap on.
Oh,
It's like, dude, you're in it, like you were a janitor at MIT, like, yes, you physically went there.
Hey,
It's pretty good.
This is my.
Yeah.
Oh, that's what I'm supposed to be doing.
Tell me, please.
Something like that.
Oh, so.
This is this girl.
How did she do nails in here?
You did your own nails?
No.
Cause
she
your
did-
nails, I was looking at
She
your
did nails
nails.
in here. These are principles.
No. Look, the little like,
And she's
acrylic.
good. And she don't wanna do
My
it.
head is like.
We're gonna tell her to start doing nails in here. She's good at it.
Listen,
Yeah.
I want to do hair.
Oh,
It takes too much time.
oh, you're talking about like, was it a Tartaria?
Yeah.
You heard about that, Tartaria? It's a whole
Do you do
like
makeup?
theory online, there's this ancient lost, this
Yeah.
Oh,
That's a
yeah, yeah.
lost civilization of Tartaria, right, like,
Oh,
that there's this like grand civilization that.
Yeah.
basically is wiped out.
Child,
I don't even.
Yeah.
Yeah.
When are y'all
This is
doing
what-
y'all senior pictures?
This is what
Mine
Slaughter
is
used
supposed
to
to be
do, like,
mine's supposed to be-
it's like this
But somebody
grand
said-
opulence for Roman
I don't know.
architecture,
Here's
look
what-
at
I
this
just
today.
don't wanna take
And
it.
then Prince, like,
They said
don't
we
forget
can
what
take
they
it
took
next to
from
us.
you.
Okay, so is this what your graph looks like?
Yeah,
No.
but I made the dots smaller.
That's what mine look like.
Okay, I did it wrong.
So here's the command.
Okay.
So we're gonna have data refine and then aesthetics is X is equal to metro. The price doesn't change. So here, all
Oh.
you've done is
I
take
did, I didn't.
a square foot and put in metro,
Yeah,
Yeah.
okay?
that's what I.
Now, to be able to put in the
Mine.
line, all I have to do is take this thing,
So you didn't
copy
do the
that,
shape.
and then take
Yeah.
this guy and plus it, and add that, execute that. Oh, you are right.
Upsie.
Yeah, so we get that.
I did.
Is that what you got, Taylor?
My dots look smaller.
My dots are, huge.
Your dots are huge.
No,
Okay,
they-
so let me
mine's
go
small.
ahead and let's do,
I mean, they were small,
Um,
yeah, mine are small, but now they're huge.
I'm gonna change beds
I think it looks like.
to metro distance.
Excuse me.
Oh,
And we get,
if you
this is
take out-
my output here.
I'm confused.
If you take out shape,
Why are we doing price?
Oh.
I thought we were doing price per square feet.
No, we're doing.
No, we're
metro.
doing, what's the relationship between price and the metro
We already
distance?
did square feet.
We did.
So,
Okay.
sorry if I didn't make that clear. But now I look at this and I see that the coefficient is minus 24
And it's not.
1,000.
significant.
and it's not
Oh, now it's-
significant. And if I look at this line, why is it not significant?
Cause it's constant.
Because it's flat, it's not positive or negative, it's not upward sloping, so there's really no relationship between prices
And metro.
and metro distance.
Oh, his is more spread out because his graph is like up. That's why ours looks so close to you.
Yeah,
And all I need to do is simply come over here and see that there's no asterisks at all. So it's neither significant at the 90th percentile, the 99th percentile, or the 99.9 percentile. So would you go and tell the mayor that access to the metro will be important or not?
nah.
It's not. And if I break this up again in terms of distance from the metro, just, like the same thing, you could do exactly what you've done thus far earlier on your project, where you're just looking at conditional t-tests on the average price for a home that's, say, within a quarter mile of the metro relative to something that's half a mile from the metro. Taylor?
So how do you go about deciding which variables you want to run a regression for?
So the proper way of doing that is you have to come to your question with some theory or intuition as to what should be included. Now, this is a valid regression. There's nothing wrong with it. You came in and you said, hey, I think access to the metro would be important for price. I myself would value that. But is that actually the case?
Theory as in like,
Did anything I say sound stupid? In the sense of, that seems logical, right? That certain people like to be close to the metro line. It allows them to walk. It's like people live in Decatur because they can get on the metro or on MARTA and come into work real easily. I take MARTA every day. Having access to North Springs was important to me, so I bought a house in that area. So it does, but in general, does that hold? That access to the metro line is important for the price of the house. What would you conclude? No.
closer to.
Nothing about your question was invalid. It was a valid question. It made sense. You have policymakers ask questions like this all the time. But if they came to you and you did the analysis, you would go back to them and say, yeah, this doesn't matter. Don't waste your time. Jan?
Like, I don't get it, because, like, I understand, like, the correlation's low, but it says it's significant.
No, it doesn't say
There's no
significant.
Oh,
The
okay.
There's an intercept term.
The intercept is significant because it's explaining everything.
So at the
And
intercept,
that means that it's not helpful. Just saying, I can just tell you the average price because that's all that's being told here.
Okay.
Good question, because otherwise our point didn't come through. And the figure, I mean, before I even plotted that line and I look at the figure, it's not nearly as nice and, kind of have that nice kind of cone up in a linear manner. So, yeah. Not surprised. But it makes sense to you, right? It makes sense? So, just again, do we understand what the significance means? This is telling how robust you are with regards to saying, I'm rejecting the null. And I have a lot of robustness here, not as much robustness here. So the more asterisks, the more significance against the null. And that's something that's nice to kind of talk through with people, because it helps you, clear your mind and say things in a way that's understandable, where when you just kind of do it in isolation, it's harder for you to conceptualize. Vocalizing it makes it a lot easier. All right, so next week, you have your rough draft. The week after that, we have our presentations, which I'm excited about. That'll be fun. We'll talk more about those next week. And if you come with questions about your presentations, be happy to address them and go through them and actually give you feedback if you've already got some slides put together. What's the general PowerPoint, or what are you gonna?
Canva. No, is it Canvas?
No, it's
Or- Canva. Yeah, I'm sorry, I always get this confused. Canva, it's like,
But you can copy and you can do snippet and plug everything in the chat.
yeah.
Using PowerPoint.
PowerPoint's really.
Okay.
Oh, I can't.
All right, well, I can't help you on that, because I don't even know what it is. But I can help you on how to cut and paste.
It makes it cute
Yeah, it
But-
does.
for convenience, like PowerPoint is like
But
easy.
when
Well,
you-
not
if you was to go
necessarily
to a
PowerPoint.
job- If you was to go to a job, are you gonna use Canva?
Yes.
No,
No.
They create some.
PowerPoint.
First of all, I did my research project in Canva, and it was very nice.
Yeah, and
Professor
I was
Sybil
like-
let you do it in,
Too many pictures.
I know I did research day, and we had to choose the paper that we wrote, and we presented our research day project in Canva. So I
In
don't know.
case competitions, everyone used Canva. So I was like, okay, so this is the
We
standard.
can make it look professional.
you run with what you know.
Yeah.
I'm all for,
Yeah.
It's a little
being open-minded and letting you run with what you know. Okay, that's it. Have a great weekend.
Get out.
You can,
Yeah.
things are good.
Thank you.
Then,
Let me go.
Well done.
I think this was one of the better ways that we've